Okay. So here's a region. Okay, let me draw them. I think we did problems before. Let me redo it again. This is a picture, and x plus y equals 2, and x equals y squared. So x equals y squared is open to the left of the parabola, and this is a line. Okay. Now after you find the intersection points, you will get, here's 1 and 1, right? And this is going to be, I think it's going to be y is 2, x is 4. Okay. So we want to find out both the x coordinate and the y coordinate, right? So well, if you use a formula, the reason you have trouble is if you use a formula, one of the formulas in the book, and in probably have trouble because you cannot use the x variable, y variable to integrate. Okay, you have to view the graph going that way. Okay, so this is a 1, this is a -2. Yeah, -2. Okay, so the write down two formulas, and this function will be x equals 2 minus y, and this function x equals y squared. So the first function, the top function, the bottom function will be the top function will be 2 minus y, and the bottom function y squared. So if we want to use a formula x bar, right, and the y bar, I think it's a y bar first. Y bar is just the integral of the the difference, right, from -2 to y. The difference of these two functions, which is 2 minus y squared dy. Okay, everything should be converted to y variable. Okay, and then if you really want to use a formula in the book, so you have to find the y bar first, and this -2 to y, and that is going to be, I think it's a y bar first. Okay, and that is going to be y, and the 2 minus y squared dy. Okay, so this is the first function, second function. Now, if you really want to find x bar, still use a y variable. The bottom part is still the same. Okay, the top part will be half of the first function square minus second function square. Okay, so that if we can write down those two, then you solve the problem. Okay, so yeah, there are two types of formulas. If you really just want to memorize formula, that's fine. One is we use this function, right? The region is given by this two functions. So y equals f of x, y equals g of x, and this is from C A to B, right? Then the centroid x bar is going to be integral of f of x minus g of x dx, and here x f of x minus g of x dx. Okay, and and the y bar, we still use the same variable in the integral. Then here is going to be f of x squared minus g of x squared dx. Okay, and if the region, okay, are bounded by two functions, x equals f of y, x equals g of y, then all you have to do is replace everything by replace x by y. But be careful which one is first. Okay, so this is a picture, right? Okay, so here's x equals f of y, x equals g of y, and this is C and D. Okay, and in this case, the central x bar, y bar, yeah, the y bar should be using the top function, right? Replace, yeah, and the x just using the above formula, just replace x by y everywhere. So y is going to be integral here C and D, and here's f of y minus gy. Now, without understanding, I should say, you probably don't know why this happens, right? Why we have to write it like this, right? And then replace x by y, okay? Then x bar, and then this is a CD, and this is still f of y minus g of y dy, and here, and the c and d, half of f of y squared minus gy squared dy. So if you use it, yeah, we just use these two formulas to get the centroid of the region, okay? But you know how to evaluate the integrals. All right, so this is the problem, okay? I'm going to actually try to do a similar problem here. Okay, let's see what it is. All right, so here's a question, okay? Find the centroid of the region, okay, bounded by y equals x squared, x equals y squared, okay? So you are not given the graph even. Step one, okay? Step one, so you're going to have a two, you're given two curves, right? You have to draw that, okay? Y equals x, looks like that. X equals y squared, looks like that, okay? Okay, and then this will be the as the intersection point. You have to find the two intersections. So clearly, this is the intersection point. The other one, I was thinking I can even just write down this. You know, it's one because 1 equals 1 squared. Okay. Now, what is the best way to set up the integral for x bar, y bar? Okay. Well, x bar, you can always project, you know, I try not to use the formula I mentioned, okay? This is the length, right? So at every point, if you project this region to the x-axis, and you get a density function, okay? The density function is the difference of these two functions. The one on the top is going to be square root x, okay? Because that curve is going to be y equals square root x, okay? And the one at the bottom, just x squared, okay? That is a function. So x bar is going to be the centroid of the interval from 0 to 1 with a density function, right? So that's why this is from 0 to 1, rho of x dx, and then from 0 to 1, x, okay? So that is the formula, okay? So where rho of x is square of x minus x squared y squared. Now, you don't need you can also use a formula in the book, but it's harder to understand why it says the first function square minus second function square, right? But I'm going to write down that formula if we still use x square root, okay? And it says half of the top function square minus the bottom function square, okay? That is the formula. But I'm trying to use the same idea for the x bar. I project this region onto the y-axis. So the centroid, the y bar should be the centroid of the interval on the y-axis. Okay, on the y-axis with the density function. The density function is a function of y. Okay, this is a projection of that line. This is the length of that line segment. So the density function rho of y is going to be the difference of this two x coordinate. The one on the right is going to be square root of yeah, y equals x squared, so square of y. The one on the left, and that is x is y squared, so it's y squared. So very similar. Okay. So y bar is going to be the integral from 0 to 1, rho over y dy. Okay. And you get exactly the same result. Okay. You get exactly the same result. Okay. In other words, the denominator is same denominator. Okay. So this two integral is always going to be the same. Okay. Rho over y dy is the same as rho of x. So this is not yeah, if you use this one as a rho 1, that is a rho 2, it's not the exact same function with different variables. Okay, it's the integral from this, and what is my x? Okay, x to the 1/2 minus x squared dx. Then let's find the area of that region, and that is going to be 2 over 3x, 3 over 2, minus 1 over 3x cubed. Okay, evaluate to end point. So the answer is 1/3. That is the area of that region. So what I want to say that this two numerator give the same value. Okay, regardless, yeah, the integral. Okay, I want to show that. What is that? It's the integral from y, and here, and the square y minus y squared, right? dy. Okay, let's evaluate this integral. This is the integral, and here y to the 3 over 2 minus y cubed. The antiderivative is 2 over 5, y to the 5 over 2, minus a quarter, y to the 4th power. So it's 2 over 5 minus 1/4. All right, so 8 minus 5 is 3. 20 over 3. That's 3 over 20, right? Yeah. All right. So finally, yeah, this is we should get the same result if I use that integral without understanding what's that meaning. Okay, and that's from 0 to 1, 1/2. It's surprising. Compare different integrals, right? X minus x to the 4th power. Okay, so let's find the antiderivative. I should get 3 over 20. It's measured. Antiderivative of x is going to be half of x squared. Antiderivative of x to the 4th is 1/5 x to the 5th. Okay, so you are going to get 1/2 minus 1/5. Okay. Okay, it's 1/2. Here's a 10. 5 minus 2 is 3. And you get 3 over 20. Great. You see? But the geometric meaning of this is not, it's more complicated. Okay. It's not easy to understand. I already explained to you before how do we get this formula, but it's not easy. But the other one, okay, this formula will be easier to understand. You just find the centroid of the interval on the y-axis. That interval is a projection of that region onto that interval. Okay, and you get a y bar, right? So anyway, so y bar is going to be 3 over 20. Doesn't matter which formula you use. And this is x. What is x bar? X. And what is it? What is the area? Area is this. So it's going to be 9 over 20. It's about 1/2. Okay. So this is how do we get the answer? Okay. However, if you look at the picture by this of the symmetry of the picture, this is a picture symmetric about the line, midline y equals x. So in this case, you really don't need it. So x bar should be equal to y bar. Okay, the centroid must be on the line. So if you get x bar, then then that must be equal. Okay, so you just need to compute the x bar, and then you get the same value for the y bar. Okay, yeah. Okay. I didn't even get x bar here. I didn't compute it, right? What is x bar, right? X bar is it's a same. Okay, I did not calculate this integral. Okay, this is x bar, integral of this function. Okay, so you're going to get the same result. Okay, so that's why by the symmetry, x bar equals y bar. So that's why it's going to be 9/20. Okay, you don't need to waste time to compute the x bar. Right. Now, I think the difficult part is about area of the surface, the length of the curve, area surface. It's a little bit more challenging because not everybody know how to set up the integral correctly. Okay, there's no way you can copy it in the book. Okay, so let me do the standard one. Okay, find I'm probably just want to set up the integral. Okay, set up an integral for the area, okay, of the surface. Okay, this surface is generated about. I want to set the integral for two integral for each case. Okay, one yeah. So x is going to be n y squared. That's all I want to write down. Okay, this is a general and the y is between 0 and 1. Okay. Okay, the first case is generate about by rotating about the x-axis. Another surface is generated by rotating about the y-axis. So you're going to get two different pictures about the x-axis, right? So this is a curve, right? And the y equals, yeah, so this is a curve from here to here, from 0 to 1, okay? So it's generated about x-axis, okay? That's the first one. Second one, okay, looks like that, okay? Totally different graphs. You have to be careful when you read it, okay? Okay, I do have a couple questions about the quiz and the midterm. The quiz is always cover what is you learned in last week. Okay, we only have two sections. I think so. So section 8.8.3. Okay, it's on my syllabus. It's already made. Not on the schedule. I posted it, right? Quiz 7 covers 8.2, 8.3. Midterm, there's no study guideline. Cover all the sections. Okay, you have to understand all the material. It takes a quick midterm. Okay, and that's why I discussed some problems. Those are the problems, so I pay more attention in the class. And I already post a sample test. Maybe you can do it as a guideline. Okay, I already posted a sample test, 2 sample tests. I think it was also with solutions. Don't look at solutions. You do it by yourself after you prepare. Go over the material. Okay, then check your answer, check your solution to see if you get 100%. Okay, don't just read a solution and then after you spend 2 minutes you give up. That's not going to improve it. Understanding somebody else's work will not help you too much. Maybe 5% improve. So the same problem. If I change the numbers, are you able to do it? Probably not. So you have to spend time on some problems challenging problems by yourself, right? And that's my experience. When I was a student, I study some calculus problems. I was travel and I spend actually 1 hour sometimes. I go with the material because when you try to solve the problem, you also look at the book, right? You look at the examples. So this is a process of going over the material, not just trying to solve the problem. Then once you solve the problem, you also review the material. That's why you understand better. But if somebody tell you how to do that problem, you only focus on that part, okay? And more likely, we're not going to give the exact same problem, okay? Even you can memorize it. Okay, got it? Yeah. So the sample tests are already posted, okay? You can after you prepare, for the test, and you can take it at home, take this sample test, and then you can grade it by yourself to see how many points you can get. Okay. Okay, so we have for example, maybe I will ask you to set up integral, not evaluate, 2 integrals for each of the picture. Okay, can you do that? Okay, just focus on the first one. Set up 2 integrals. Yeah, integral with respect to x, integral with respect to y. Okay, for the surface generated by rotating about the x-axis. Okay, so can you do this? Yeah, can you write down 2 integrals? And I'm going to show it to you. I give you 1 minute to think about it. Okay, only to show you the picture. Okay. For those 2 pictures, the universal formula is 2 pi rs. I don't memorize this very specific one. The reason is if I shift it, if I ask you if I rotate it about another horizontal line instead of x-axis, if you don't understand if you don't understand how to apply this general formula and only memorize a specific formula, then you probably don't get it right now, right integral for the surface of it, for the area of the surface. Okay. So use this universe formula. Please write down 2 integrals for each. Okay. Give you a minute to think of. All right. I hope you already get the answers. Get 2 integrals for the first picture. Okay, step 1, what is r? Right? R is going to be this part, r, right? And this is a point, x and y, and ds is arc length element, right? ds. That's a picture I want to see. All right, so ds is going to be, I is going to be the y variable, okay, for that particular point, okay? Then depends on, it depends, yeah, it depends on integral, okay? If it's integral with respect to y variable, then that's enough. If the integral with respect to x variable, you know, x is going to be y squared, so y is going to be square x, right? This could be square x. All right, so that's going to be integral dx squared plus dy squared. And you can take dx out, you can take dy out, all right? So if this is, you can also get dx over dy. Right, so now let's try to find the area. If it is integral with respect to x, x is from 0 to 1, and it's 2 pi r, right? So I still put this one here. Then what is what r should be put there? It should be square x because we have to get the function of x. Okay, square x, and then derivative of square x is going to be this. Okay, so that is answer. Okay, that is answer. Now you can also evaluate with respect to y variable. Okay. So with respect to y variable, the interval is the same interval, okay? Just because this is a special parameter, okay? So I is gonna be y, so you don't need to make any change. And then dx over dy, okay? X is y squared, so that's why 2y squared plus 1. And I think this integral for the same area, this integral is better. You can use that to evaluate the integral. Just use the substitutions. Okay, so you can find the area quickly. All right, so that's the first problem. The second problem, yeah. So we have two integrals. You have to know. You must know how to set the integral with two variables. Okay. Because you're beyond the test. Okay, I will ask you to set up an integral in two different ways. Okay, and 5 points for each, 10 points. So it's up to you. Okay. All right. So the second one is going to be the same. This picture, right? Okay, and here take aperture point and it draws the R, right? In this picture, and ds is still ds here, right? So ds is still same. Those formulas are universal formula, right? Okay, you can take dx out, you can take dy out. And so what is r? R is different, r is just equal to x. So x, of course, is going to be y squared, right? It depends on which variable we're going to use. Okay, so the area is going to be integral. If you want to use x variable, x is from 0 to 1, 2 pi, and the first form, this is the first formula, right? This is going to be 1 plus dy over dx squared. Okay, so I'm going to put it, it's 2 pi, I is x, 1 plus y equals square x, right? Y equals square x. So when I differentiate, you get this. Okay. 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 Now I can also evaluate with respect to y variable. Okay. Y variable also runs from 0 to 1. Okay. This usually also be changed, the interval, but it's the same interval. Okay, so I use a y variable, so I have to use I is going to be y squared. And what is dx? X is y squared, so it's 2y. Okay, so you get two different integrals. Okay, you got two different integrals. I don't know which one is easy to evaluate. Maybe you cannot evaluate any of them, but you get two. You set up two integrals. Okay. All right. So why do we want to understand the general formula? Because if this is a curve, right? If I want to rotate about this line, okay, y equals 1, okay, and the rotation is like that, okay. Can you set up an integral, okay, for the area? Okay, this is still x equals y squared, right? And usually this is going to be used as a bonus problem on the final exam. Okay. Remember, on the final exam. Okay. But if you understand the idea, not as very specific formula in the book, okay, set up an integral, two integrals I want to do that with respect to x variable, with respect to y variable. And this time, I'm going to assuming y is less than 0 and greater than 2, and I change the interval a little bit. So x will be from 0 to 4, okay? So that point is going to be 4 and 2, okay? All right, set up two integrals, yeah, with respect to x and or y, okay? Okay, please do this. I give you a couple minutes. I hope some of you are able to set up the integral, okay? All right, I hope you get the answer, okay? So you still have to pick up a point on the curve, not the other one on the top, okay? So what is my radius? The radius here is r, okay? So you write down the formula for the radius. I is going to be this time, okay? This y is going to be 2, right? So it's 2 minus y variable. Okay, that is a difference here, okay? And you are not, yeah, you have to draw the radius, okay? And the relationship between x and y, y could be also square of x, right? Depends which one you want to use, which variable you're going to use. That's it. We're done. Okay. So, and ds is going to be square of dx squared plus dy squared. And you can take x out, you can take y out, dy out. Okay. So if you take x out, dx out, then dy over dx, dy over x, so y is the square of x, so it's dx, okay? If you take dy out, is a dx over dy, okay? It's gonna be that, okay? Because x is 2y squared, is y squared, differential. Dx over dy is gonna be 2y, okay? So, okay, you are setting, the area is gonna be integral of 2 pi r ds. Now if you use the x variable, okay, 2 pi, 2 minus square x, and the square root, and I think this is answer, right? Yeah, ds. X is from 0 to 4. Okay. Now, if we use a y variable, y is from 0 to 2, 2 pi. What is r? R is 2 minus y. Is 2y squared plus 1. Okay, right? So this is my ds. This is r. This is r. This is ds. Okay. You see? That's how they get answers. I hope you get an idea. Okay. But you also have to draw the picture correctly. Right. There's other problems about of the length of the curve. Okay. So if we have a, yeah, this is a curve, right? The curve can be okay. So you take an aperture point on the curve. I don't know how to describe the curve right now, right? I know there's a curve in the xy plane, right? So the so-called ds is going to square dx squared plus dy squared. If you draw the triangle, and that's what you got. Okay. The length is going to be this is uniform. It's a much simpler formula than the surface, than the area of the surface. Okay, just ds. Then it's up to you which variable you're going to use. You want to use x variable, then okay, then you write as right, and you have to you also have to decide. You have to determine the interval from A to B, right? So it depends on the problem. If you use a y variable, then you take dy out, okay? All right, so now I'm going to think about some examples. Okay, let's see. Okay. Find the length of the curve. Okay. Given by the following equation. Okay, let me Yeah, let me give you an example. Y equals, let's do this first. Okay, x is between 0 and 1. All right, so the function looks pretty ugly, right? Okay. Now, you don't need to draw the graph. You know x from between 0 and 1, right? All you have to do is find and write down the formula. L means the length, A means the area. The integral from 0 to 1. It's 1 plus dy over dx squared and dx. Okay. So when you see a radical, say, oh my God, probably I'm not able to evaluate integral. So more likely, you are going to express the terms inside the radical as a square of something, right? Then you can solve the problem. So when you differentiate the first term, I get 1/2, okay? Then have a 1/2 x to the negative 1/2 squared dx. Okay, so be careful, you know, when you express it. So you multiply this out, right? So you get you get the 1/2 square plus I'm not getting the square, just keep it. Okay, then minus twice of that is 1/2. Okay, so why there's negative? Because this is a difference of two terms. But when you get these two combined, you change it minus to plus. So this should be the square of something, similar term, but as instead of subtraction, here should be addition. Okay, so you get 1/2 x to the 1/2 minus. Okay, then you can get the radical. Okay, it's going to be, but be careful, you know, it's possible to be negative. That's what I want to tell you. Okay, because when x getting close, which one should be first? This is a plus, that doesn't matter. Okay, if this is a plus, this doesn't matter. They both are positive. Okay, so dx. Then you find the antiderivative. Then you find the antiderivative of each term. Okay, so it's 1/2. Here's 2/3 x to the 3/2. And this is just x to the 1/2, I guess. Yeah, when you differentiate that. Yeah. And then evaluate 2 endpoints. That'd be 1/3 plus 1, it's a 4/3. So this is a fraction. Okay, it's a fraction. Okay. Okay. Now let's take a look at another problem. The integral from 0 to 1, it's going to be x plus 2, x plus 1. Okay, and dx. All right, how do we solve this problem? Do you have any ideas? I even can put a square root here. You know what, right? So I give you a half minute to think about this. All right, got it? Okay, so when you look at this, how do you find the antiderivative, right? So when you see a log, you have to, the best way to do is to modify, okay, using the property, here's x plus 2 divided by x plus 1 there. Then you have to separate, okay? Now the question is, how do we evaluate the integral natural log of x plus k, right? How do you evaluate this one? Well, you can use a integration by parts. This is a pretty good problem, actually, right? Integration by parts. So you can exchange it, okay, and then this is a v, right? This is a u, right? And then exchange this uv and the minus v and the derivative of this x plus k dx. Okay, so then integral of that function, okay? So it's actually the degree of the numerator is the same as it's x over, right, of x plus k. So what I'm trying to do is I quickly change it to 1 minus k x plus k. You can use a long division to get it, okay? So the first one is constant 1, so I can just write down x. The second one is k, natural log of x plus k. Yeah, we assume, at this moment, you probably don't need the absolute value here because in above integral, x plus 2 is always positive, okay? And plus constant. But you can also double check whether this is the correct answer, antiderivative. Okay, when you differentiate, I'm going to, check. I'm going to differentiate. Differentiate with respect to, x, again, natural log of x plus k. Then I differentiate with respect to, differential second term, then minus 1 plus k, x plus k. So add them together, and I get just natural x plus k. It's great. So this is correct, okay, antiderivative. So this is what we get, right? Remember, I can also write it as x plus k natural log of x plus k minus x, okay? Because that's what I got, okay? Because there are x here, k here. So that's two terms. All right, now let's go back to our integral, right? Our integrals is natural log of, right? And this is integral from 0 to 1, I remember, right? From 0 to 1. So I find the antiderivative of each of them, right? Antiderivative of the natural log x plus 2 minus, right? Yeah, let me put this first. Okay, the antiderivative, the first one is x plus 2 natural equal plus 2 minus x. The second one, I have to subtract it. Then the minus x plus positive x. Actually, now x is gone. This x is gone because that's the same x. Done, almost done, right? When x equals 1, I get 3, natural log of 3, and minus 2, natural log of 2. And then I plug 0. I get 2, natural log of 2. And the natural log of 1 is 0, so it's gone. So the answer will be 3 natural log of 3 minus 4 natural log of 2. I can also combine them into one, okay? I get natural log of 3 cubed divided by natural log of 2, right? 2 to the 4th power. Okay. Yeah. Right. And again, let's simplify a little bit. So that'll be 3 square 3, and here's a 4. Okay. So that is answer. Exact value. Okay. So let's go over this problem. I tried to evaluate this integral. So I simplify. Express as an integral of the linear. For these two terms, the difference. So all I had to do is just find the antiderivative of that function. So I just assuming x plus k. Okay, assuming x plus k, then use the integration of a part, and then find the antiderivative. I double check it. I want to make sure this is correct, right? Then I differentiate. I get x plus k. Then you just evaluate integral, use the antiderivative, right? Using the antiderivative, and you find this simple. Okay, so we are ready for the quiz. Okay, I'll stop here, and we have one more review class, kind of. We have plenty of time. Okay, I hope you do well on the quizzes and on the midterm. I'm going to stop here.